Hello students, myself Dr.Purna, Government VUIT PG Autonomous College, HOD and Professor in Physics. Now today I am going to present about the topic Theory of Scattering, and this is mentioned in the syllabus of M.Sc. second semester Physics. My contents are Introduction, Scattering, Laboratory and Center of Mass References, Scattering Theory, Nucleon Scattering, then Neutron Proton Scattering at low energy, Neutron Proton Scattering at high energy, and at the end references. So let me start with the topic. Now, the topic is Introduction. Now, what is scattering? Here we will talk about the scattering of nucleons. A nucleon is one of the particles that makes up the atomic nucleus. So, in the nucleus, as we know, neutrons and protons are present. So, these two particles are known as nucleons. Each atomic nucleus consists of one or more nucleon. In each atom, in turn, it consists of cluster of nucleons surrounded by one or more electron. As the picture shows, this is the atom and this is the nucleus. The atomic radius is of the order of 10 raised to the power of minus 8 centimeter, and the nucleus radius is about 10 raised to the power of minus 12 centimeter. Now, protons are surrounded around the nucleus in different orbits. Now, the protons are and neutrons are of the size 10 raised to the power of minus 13 centimeters, and the quarks are of the order of 10 raised to the power of minus 16 centimeters. Now, scatterings are of two types. Now, when a ray of light falls on some matter, then it gets scattered. Now, scattering are of two types, that is elastic scattering and inelastic scattering. These two types of scattering are there. Now, when we talk about the scattering in laboratory and center of mass frames. Now, what is laboratory frame? Now, the first picture shows the L system and the second picture shows the center of mass system. Now, in the laboratory system, the target particle is at rest, and this is known as laboratory system. And in the center of mass system, the center of mass is at rest. The relation between angles of theta and center of mass is as shown in the figure. Now the process of scattering is like this. Now the incident plane wave is coming like this, and this is the scattering center, that is the target particle is present here. Now the detector we have placed here. Now what will happen? The incident particle will come and collide with the target particle. Now, some of the particles will pass through it, which passes unscattered. So this is known as unscattered particle, and the scattering spherical waves are represented like this. The scattering particles are moved at different angles, and it is detected by the detector. Now, scattering theory. The theory of scattering, if we talk about the theory of scattering. Now, let us see in this picture, we have shown that this is the target particle, the incident particle is coming like this, and the target particles, it collides, some of the incident particles collides with the target particle and deflected at an angle theta. Now, this makes an angle theta. That means it makes an angle theta with the incident particle. Now here it forms a cone shaped now this is the spherical wave, and it forms a cone shape which is known as solid angle. The angle with which it makes is along this axis. This is d phi, and the small angle which forms here, this is d theta. That means some of the particles are deflected along this theta angle, and some of the particles are present here, are deflected along the angle theta plus d theta. So this forms, d theta forms a ring shaped here, and what is d phi? We have taken some portion of this angle which is known as d phi. So this portion is the angle which is formed here. This is d phi angle. Now, the radius of the, what is the definition of the solid angle? Solid angle is represented by d omega, which is equal to d phi times r sin theta multiplied by r into d theta divided by radius square. That means the cone shape which it forms, the area of the cone which it forms, this is the area of the cone which it forms. It is given by d omega, and finally d omega equal to sine of theta multiplied by d theta into d phi. This is given by solid angle. Now d omega can be also solid angle of the entire ring. This is given by 2 pi sine theta into d theta, and total angle form, it is given by sine theta d theta into d phi. Now let us define differential scattering cross section. Now, how will you define differential scattering cross section? Differential scattering cross section is sigma, which is a function of theta and phi. This is given by the expression d omega, which is function of d theta and d phi divided by d omega. Here d omega is the solid angle. The total scattering cross section can be determined by integrating the above expression and if we integrate it, then we will get the total scattering cross section. So sigma, which is function of theta and phi, and this is given by integration sigma theta into d omega. Now as it is the function of phi and theta, so we will integrate it twice. That is, limits will be phi equal to 0 to 2 pi, and this is limits for theta will be 0 to pi, and we will write sigma, which is function of theta and phi, multiplied by sine theta into d theta. So scattering cross section can also be determined like this. If n is the total number of particles which is crossing per unit time, then we will integrate it from n0 to nt. Now this is given by minus dt by n, and integration for the time 0 to t we will write n sigma into dx. So if we integrate it, we will get log to the base e nt upon n equal to minus n sigma into t. Therefore, nt is given by n0 e raised to the power of minus sigma t. Now, let us talk about neutron-proton scattering. Here, now this is the incident particle. Now this is the nucleus where neutrons and protons are present here. The black one is shows the neutrons which is bombarded, and let us suppose this is the nucleus where neutrons and protons are orange in color. So it is shown like this. Now it is detected by the detector. Now before scattering, this is the diagram for the scattering, initial scattering, before the scattering. Now after the scattering takes place, the diagram is shown like this. Now this is the scatterer which is colliding with the target. Now after collision, this comes here and it collides with it, and the particle which is deflected is detected by the detector. The orange shape, as I told you, this is the proton which is detected by the detector. So one particle is detected by the detector after scattering. Now, in the next one, we will talk about the neutron-proton scattering at low energy. So, this is my first part of the video. Now, we will talk about in the second part.